Welcome back, students. Today we're going to be working on our last section in the limits unit. This section is about infinite limits, and it's a description of unbounded behavior. So a limit that fails to exist due to unbounded behavior of a function as x approaches c is called an infinite limit. Called an infinite limit. And we will use the infinity symbol. So we'll have the limit as x approaches c of f of x equaling either infinity, or the limit as x approaches c of f of x equaling negative infinity, as a description. And I really want you to think of it as that word. It's a description of how the limit fails to exist. So I want you to not think that I'm redefining what we said before. If a function goes off to infinity or is unbounded in either direction, the limit does not exist. However, we are describing what's going on. So please do not take the equal sign as an indication that the limit exists. It still does not exist. We're just redefining what is going on. We're describing what is going on. So the types of functions that we typically see unbounded behavior for will be rational functions. And you'll know those algebraically when you encounter a numerator that does not equal 0, but a denominator that does equal 0. And at those places, we would see an infinite limit. So that leads us to a definition of vertical asymptotes. And although you are already familiar with the fact that vertical asymptotes occur, this is why they occur. So your definition of vertical asymptotes: if f of x approaches positive or negative infinity as x approaches c from the right or the left, then the line x equals c is a vertical asymptote of the graph of f. So you'll have the equation of a line as the vertical asymptote. I can't squeeze that in, so I'll just write it like that. All right, so then your summary theorem would be that a function of the form f of x over g of x, where for some x value f of c, does not equal 0, but g of c, your denominator, does equal 0, then that function has a vertical asymptote at x equals c, and its equation is the vertical line x equals c. So we'll look at a few examples of finding the limit with unbounded behavior, describing it as either positive infinity or negative infinity. So I'll erase this and move on to that next area. So this is down at the bottom of the front page of your notes. It says find the limit if it exists. And in part A, we're looking at a graph and the limit as x approaches 1 of f of x. So I've got the 1 right here for you. There's where x equals 1. You can see it as this dashed line. And so let's take a look at both sides of this graph. So as x is approaching 1, and you see this graph is going on to infinity. So we can describe that direction as going to infinity. As we approach 1 from the right, that graph is unbounded again, going to infinity. So your answer to whether the limit exists, the limit as x approaches 1 of f of x, still does not exist. And that is not changing. But what is changing is that we're going to describe what is happening as the limit or as x approaches 1. And for that description, we're going to say that it equals infinity because the graph is unbounded and going toward positive infinity. Now, let's compare that to part B. So part B, this would be the limit as x approaches -1. So again, I've got this right here. It's actually the vertical asymptote that you're seeing. And as we approach -1 from the left side, we can see that this is unbounded. So going to negative infinity, though. So it's going to keep decreasing. And as we approach from the right, so as we look at that graph from the right, we're going to positive infinity. And so as you look at the limit itself, the limit as x approaches -1 of f of x still does not exist. However, we can describe what is going on, and because it is going in both directions, I want to indicate that, and I'll say that by looking at positive and negative infinity. And if I wanted to just look at the one-sided limits, I could say the limit as x approaches -1 goes to negative infinity from the left, and the limit as x approaches -1 from the right goes to positive infinity. So we have some more examples that go with this. If you'll go ahead and tune into video 2, we will do the back side of your notes.